Hello, fellow friends of Euclid. It is great to be here with you today. Always an honor and privilege to be surrounded by so many young and brilliant minds as yours. Today we're doing 3-3 and 3-4. And so you have some notes. I gave you a sheet of paper. And you have had a chance to fill it out a little bit now, and let's see what you came up with and see if it matches this information. In the figure above, name an acute angle. There are a couple of them here. And that's BAC, angle BAC. You can see that's this one right here. And angle CAD, that'd be that one there. Okay, those two are acute angles. Name an obtuse angle. So let's find an obtuse angle in the figure. And there's really only one, and that's angle EAC. And you can see that that's more than 90 degrees, that angle. All right? And then it says a right angle. So there are two right angles. There's EAD and there's BAD. And then a straight angle. Straight angle is just as it describes. EAB. And of course we can name all these angles backwards. If you read them backwards, they would still be correct. All right, how did you do on number 2, finding the angle measures? Find the measures of the angles you named in question 1. No protractors. Okay, acute, angle BAC or angle CAD. All right, so the same ones that we saw. How do we figure these out? We look at the coordinates. Okay, so we can do 78 minus 30. And what does that equal? 48. So angle BAC is 48. So all we have to do is find the coordinates and find the positive number difference between them. Angle CAD, so this would be 120 minus 78, 42. Nothing too hard there. Obtuse, angle EAC. All right. So EAC, let's get a different color going here so we can distinguish. EAC, that's in green here. That's our obtuse angle. What are the coordinates? 210 and 78. So 210 minus 78. 132 degrees. Right angles, we identified EAD and BAD. We know they're 90 degrees, don't we? But the coordinates also confirm that 210 minus 120 equals 90 degrees. Same thing with 120 minus 30. Also equals 90 degrees. So 90 degrees to the right angle. And the straight angle, EAB. What are the coordinates for the straight angle? Well, the coordinates are 210 and 30. Confirms what we already know about straight angles, that they are 180 degrees. So notice that we did not use a protractor. We were given this figure with coordinates already on the figure, and this is what we have. The coordinates confirm what the protractor would tell us, but we don't have to dig out the protractor and figure it out if we already have the coordinates on our figure. What else is important in 3-3? Postulate 4, the protractor postulate. The blank and a half rotation can be numbered from 0 to 180 so the blank number blank measure angles. So what is that all about? The rays and half rotation can be numbered from 0 to 180 so the positive number differences measure angles. Postulate 4. All right? That's the protractor postulate. Very similar to the ruler postulate that you had in lesson 3-2, isn't it? Only it deals here with rays. Right? And angles here. All right, number 4, a ray is between two others in the same half rotation if and only if its coordinate is between their coordinates. So half rotation, okay, so that's 180 degrees a half rotation is. All right, so for instance, if this has a coordinate of 180 at A, and if the coordinate is 30 at C, then the way that we know that this ray BD is between them is by the fact that its coordinate, and let's say that the coordinate for this one is 120. 120 is between 30 and 180. That's how we know that. That's what this is telling us here. A ray is between two others in the same half rotation if and only if its coordinate is between their coordinates. So you might see that written 180 is greater than 120 is greater than 30, or reverse, 30 is less than 120 less than 180. So anyway, that puts BD in between BA and BC. All right, theorem 2, the betweenness of rays theorem, very similar to the betweenness of points theorem. And you can see that sort of notation here. OB is between OA and OC. Then angle AOB plus angle BOC plus angle AOC. Oh, that should be, let me show you the figure here. So OA so we have this. So angle AOB, so that would be this angle plus angle BOC, that would be this angle, equals angle AOC. So by now you have spotted the typo that's in here. So it equals angle AOC. And there's the typo. Angle AOB plus angle BOC equals angle AOC. Alright, so that's the basic part of lesson 3-3 that you need to know. 3-4, we just have a little bit of vocabulary to go over for that. It talks about bisection, which you know is to divide something into two equal parts. So a point is the midpoint of a line segment, if and only if it divides the line segment into two equal segments. So if I should have a segment here, AB, then it's got the bisector that's midpoint there. If C is the midpoint, it divides the line segment into two equal segments. A line bisects an angle if and only if it divides the angle into two equal angles. Okay? And some of this stuff you can recall, you've had a little taste of it earlier in the course. A blank is a theorem that can be easily proved as a consequence of a postulate or another theorem. That's a corollary. You want to be familiar with that word. It's kind of like a baby theorem, corollary. Number 4, if a figure coincides exactly with another figure when superimposed on it, the two figures are congruent. Corollary to the ruler postulate is the line segment has exactly one midpoint. Corollary to the protractor postulate is an angle has exactly one ray that bisects it. All right, these are the basics of these two lessons. So that should give you some framework that you can grab onto so that you know what the key points are. All right. enjoy it.